Hello and welcome to Azure Back to School. My name is Håkan Silfvernagel. I work as an AI evangelist for Supersteria, and I'm also a Microsoft AI MVP. Today I'm going to be talking about the Agentic revolution, where I'm going to share how we can build AI agents using a framework called Semantic Kernel from Microsoft. But before we start, I just want to give you a quick introduction into how this can actually look like. So let me switch over here to a demo application that we will be using throughout this session. So just a little bit of introduction and context. So where I'm from, in Sweden, we have this tradition that around Christmas, when we are handing out our Christmas gifts, then we are writing something called a Christmas rhyme. So a Christmas rhyme is something that will give some hints about what is inside the Christmas gifts without giving it all away. And these Christmas rhymes are written in a specific rhythmical pattern. So what I've done here is that I've created a Christmas rhyme generator where you can select a particular type of gift, and then we will have a generative AI generate a Christmas rhyme for that type of a gift. And in addition, it will also create an illustration, a graphic here for that gift. So let me show you how that can be done. So here we can select a gift. So let's say that we select a tie, and then we can create a rhyme. So you can see this Christmas rhyme. So here it says, to add some flair to your attire, this tie will truly inspire. With colors bright and patterns next, it's the perfect touch to make you complete. And we can also create an image and illustration for this gift. So in a short while we will have a Christmassy image that will depict this gift. So here we can see we have the Santa Claus in the background, and we have a very Christmas colored tie, and we have some other Christmas decorations like a Christmas tree and other things related to Christmas. So I will show you how we can use AI agents in order to create this type of application. But let me get back here to my presentation. So my name is Håkan Silfvernagel. I am an AI evangelist. I'm also a Microsoft AI MVP, a Microsoft Certified Trainer, and a Microsoft Certified Trainer Community Lead. And I've been working with AI and machine learning since 2018. And I have also been a subject matter expert on AI at Supersteria. And you can see, if you want to follow me or connect, feel free to connect on LinkedIn. I will give you a QR code that you can scan at the end of this session. I'm also quite involved in the local user group community here in Oslo and also elsewhere. So I'm part of the organization committee for the Norwegian.net user group in Oslo. I'm also part of organizing the Oslo AI meetup. And during the Corona, me and two other MVPs started an online AI school called AI42. And I'm running the Azure User Group Sweden together with Jonah Anderson. So now on the agenda here today, we will talk about AI assistants and AI agents and learn a little bit about the difference between these two. And we are also talking about this framework called Semantic Kernel. And we were going to run a lot of demos, both to introduce ourselves to Semantic Kernel and also to see how can we build this type of Christmas rhyme application that I demonstrated here initially. So our first question can be here. We've heard a lot about AI assistants and AI agents. And the main difference here is that with AI assistants, they are usually conversational AI like chatbots, and you communicate with them using prompts. And they will give back some sort of recommendation. It can suggest information based on the data that it has access to. And on the other hand, you have AI agents. They don't require prompts, and they can work more individual. They can plan and develop their own workflows, and they can also do decision making and take actions. So there are different types of framework that we can use here if we want to create our AI agents, and one of them is Semantic Kernel, which is an open source SDK. So it works like a middleware that sits between your AI models and your own application code. And you can write your semantic kernel in either C#, Python, or Java. And we're going to have a look at what type of capabilities these different languages provide. And a central concept in semantic kernel is the concept of a plugin, where you can add your own code as a plugin. And you can also integrate other AI services with out-of-the-box connectors. So in this slide here, we can see that depending on which language we're using, C#, Python, or Java, we get access to different types of AI services. So you can see as of now, C# has the fullest amount of services, and Python and Java has a little bit less here. So for example, for the Christmas rhyme application that we're going to build, we need to be able to create an image from text to image. So that's why we're going to be using C# for that demonstration. Then another tool that can be useful to have is called Prompty. So Prompty works both with LangChain, semantic kernel, and prompt flow. So what it is that it's it's basically a tooling so that you can much easier run your prompts inside of, for example, Visual Studio Code or inside a playground. So it looks like this. So here we have installed Prompty as a Visual Studio Code extension, and then we get a template where we can fill out a prompt, and we get also the ability here to run this prompt directly from Visual Studio Code. So then it will execute this prompt and give you the output. So it's a very useful tool in order to rapidly do prototyping and be able to change things fast and evolve and iterate. Since everything that we are working with here is text, it's very easy to change, and it's very easy to see what the results will be. So I'm going to show you in a short while how we can run this from Visual Studio Code. But we can also use it in prompt flow. So then we will get a more visual setup here. So this is like a playground where you can select with toolbox and drop-down menus, but it's basically the same type of functionality as you get from the Visual Studio Code template. And then finally, this is how we would use it in our own code here. So to begin with, we need to have set up an Azure Open AI, and we need to provide the key and the deployment name and also an endpoint. And then after that, we can create a kernel object, a semantic kernel object, and we can provide some input arguments, and then we can create a function from this Prompty file. And then using that Prompty file, we can invoke our semantic kernel here and then invoke it as a function and get a result back. So now let me switch over here to some demos. But first, the first thing that we need to set up is we need to go into the Azure portal and set up an instance here of Azure Open AI. So let me switch over here to my browser. So here we're inside the Azure portal, and then we can create a new resource. and then we can search for AI. So here's the Azure Open AI. And here we can create an Azure Open AI instance. We just need to provide it with a resource group, a region, a name, and also a pricing tier. So I have already done all of this. So we can see here that in my portal here, I already have an Azure Open AI instance. And if we go to the AI Foundry portal, what we can do is we can deploy a model, one or several models that we then can use. Yeah, so now we've loaded the Azure AI Foundry, and in the Foundry we will get a playground here where we can chat with our model. And first thing that we need to do is we need to deploy our model. So we can see here that here I've deployed a number of different models. To the ones that we are going to make use of is the GTP4 model, and also the DALL-E 3 model in order to create this Christmas illustration. So basically this is something that you need to do as a first step before you start with the semantic kernel or Prompty. So once we have this set up, then we can have a little bit more look here on semantic kernel. So let me switch over here to Visual Studio. So here in our first example, we're gonna have a look here at how we can use the semantic kernel to do chat completion. So what we do here is we create a semantic kernel object, and we're using then the deployment name from the Azure OpenAI instance that we've deployed here in the Azure portal. So we need the deployment name, the endpoint, and an API key. And then we can create a kernel object, and then we can invoke this kernel with a prompt here. So here is a prompt, what color is the sky, and then we write out on the console here. So if we run this example, and then we can see that our prompt was what is the color of the sky, and here we get the information about the color of the sky is typically blue, and so on and so forth. But what we also can do here is we can provide some input arguments here to our semantic kernel object. So here we provide it with an argument that the topic is in this instance it's C, and then we invoke it with what color is the, and then topic. And we provide the topic here through our arguments. So if we run this one, then we see here that the color of the sea can vary widely depending on the variety of factors. And then in a third example here, we can provide some more execution settings to our LLM. So here we provide it again here with an argument with the topic, but then we also provide it with some OpenAI prompt execution settings. So we set the maximum number of tokens, we set the temperature, and here we set the topic here that the topic should be dogs. So let us run this again here. Yeah, so here we wanted to have a story here about dogs, And we can see here that it's provided us a story here about a group of dogs who were the best friends here. And so we see that that also worked. So, but the real strength here of using Semantic Kernel lies in a concept called a plugin. So now in our next example, we will again here create Semantic Kernel builder object and create a Semantic Kernel object. Then after that, we will provide it with a path here for where we have our plugin. And then we will load our plugin and use that plugin in order to do something. So here we have a directory here called plugins, and then we have a fun plugin, and then we have something called joke, which is our plugin. And we have both a config.json file where we are giving it the description that this plugin is used to generate a funny joke. And we have again here maximum number of tokens and temperature and so on. And then we also have here a Semantic Kernel prompt. So here it says write exactly one joke or humorous story about the topic below, and joke must be G-rated, workplace, family safe, no sexism, racism or other bias, and be creative and funny, I want to laugh. And then we provide it with the input that we get here. So, so here we can see that here we provide the kernel arguments with the input, which is the topic here, time travel to dinosaur age. So then we want to have a joke about that, time travel to dinosaur age. So let's run this. So here comes the joke here. Why did the time traveler bring a ladder to the dinosaur age? Because they heard the T-Rex was a little short on friends and wanted to help him reach new heights in socializing. So I'm not going to judge the quality here of that joke, but it is a joke. So now we have seen one way of creating these plugins, but we can also create the plugin in code. So let us have a look at another example. So here in this example, we are again creating our Semantic Kernel builder, and we are building our kernel objects. And then we add our plugin here from a code file. So we have a class here called lights plugin, and we add our plugins from that class. So if we have a look here, we have a directory called plugins, where we have a folder called lights, and in that folder we have the lights plugin. So the lights plugin is an abstraction for physical lights. So here we can see that we have a table lamp, a porch light, and a candelier. And then they have different properties. Is it on or off, brightness, and so on. And we also have some functions that we can call. So these functions, they have been decorated. So we can see here that, for example, this has been decorated with a kernel function. So then Semantic Kernel knows that it can use this this function. And it also has a description, says gets a list of lights and their current state. And it returns an array of lights. Have another one, get state. So that gets the state of light. Is it on or off? And it returns the state of the light. And we can also change the state of a light. So then it returns the updated state of the light. So that's the way that plugin works. So then if we run this thing here, then we can see here that we are asking please turn on the lamp, which is the table lamp. So let's run this. So now we can see here that the agent responses back here that the table lamp has been successfully turned on. And the main idea here with using the plugins concept is that for us as developers, we didn't need to write any application code in order to turn this lamp on. Instead, we could use this Semantic Kernel agent, and the agent can figure out which function should I call in order to turn on the light. We didn't need to give it any type of instructions, but it could figure that out by itself. So that's the strength here of using the plugins. And in our next example, we can also see that it can also do planning of function execution. So here we have the same plugin as we had before here, the light plugin. And here what we do is we again create a semantic kernel object, and we build the semantic kernel. And then after that, we add our lights plugin. And then we are creating a loop here where we can communicate here with our semantic kernel. And we can ask it to do things for us. So let us run this. So here we can see what are the state of the lights. So we can get the state of each light, and then we can ask it to switch state of the table lamp. So the table lamp was off, and now it says that the table lamp has been turned on. And give me the state of all. Then we can ask it to provide the state of all lights here again, and then we can ask it to switch the state of all lights. So now we can see that it's actually switched the state here of all the different lights. So then it needed to do some planning. It needed to figure out the type of lights that are available, and it needs to switch each independent light and then report back the status for each light. And it did all of this without us having to write any type of code, but using this smart AI agent, the AI agent could figure out and do planning and execution here of our code. And then the last thing that I wanted to show here is is how we can use memory here in our applications. So here we are providing it with another text embedding model, and then we are creating a semantic text memory where we are using this text embedding service here in order to store the text embeddings for the information that we have here. So we create a memory collection, which is a memory collection about the person. So here we can see that my name is Andrea. I currently work as a tourist operator. I live in Seattle, and I've been living there since 2005, and so on. So we save all of this in our memory collection, and then after that we have an array of questions. What is your name? Where do you live? And so on. And then it just goes, it searches inside this memory collection, and it prints out the answer and also a probability for each answer. So let us run this. So here we can see here what is my name, and then it says that with 83% chance the name is Andrea, and with 82% chance it's that they currently live in Seattle and they've been living there since 2005. So this is just a simple example of demonstrating how we can make use of memory. And this is an in-process memory, but you could also save this in a database. There's a specific interface that you need to implement, but if you do that, you can save it in a database to store it, so that you have it accessible after you've turned off your application. So this was a quick introduction here to Semantic Kernel. So we've seen how we can use Semantic Kernel and how we can create plugins in order for our Semantic Kernel to be able to execute different types of functionality. And the main point here was to demonstrate that we didn't need to write any additional application code, but instead, since we're using the semantic kernel can by itself figure out which type of function should I call and also in which order, so it can do both planning and execution. So now we're gonna switch topic a little bit here to go to demonstrate promptly. So now in our second part, I would like to show you how you can use Prompty. So Prompty is an extension in Visual Studio Code. So we can see here in Visual Studio Code, we have the Prompty extension for Visual Studio Code that we have installed. And after we have installed it, then we need to set it up. So we can go to settings, our settings.json file. And here we do some model configurations for Prompty. So we set up the connection to the Azure Open AI instance that we installed previously in the Azure portal. We need to provide it with our Azure Open AI endpoint, our Azure Open AI deployment name, and our Azure Open AI API key. And when we've done that, we can use a predefined template that we can have as a starting point for development. So in this case, we have this Prompty template where we give a description. So this Prompty template is a prompt that uses a gift item as an input and creates a Christmas rhyme back as an output. And we can see here also in the Prompty template we need to do the configuration. We say that we are providing it with an Azure Open AI instance, and we provide it with the endpoint, the deployment name, and the API version. Then we provide it with some context, and here it says that you should provide a Christmas rhyme for a particular gift. The rhymes should be in the following format, and after that I'm providing examples here for how the Christmas rhyme should be set up. And we also have a system prompt. You are an AI assistant who helps people with rhymes for their Christmas gifts. As the assistant, you will write a rhyme based on the gift item and answer in a personable manner, and even add some personal flair with appropriate emojis. Respond using the JSON format by including the original gift and the rhyme. And we also have some more context here for our Prompty file. And now, since we installed this Prompty extension, we can run this directly here in Visual Studio Code. So let us do this. So here we can see that our Prompty is calling the Azure Open AI instance that we deployed in Azure previously. And then we can also see here the result. So the gift here was a cozy blanket, and then the rhyme is, on chilly nights you'll feel so snug, with this cozy blanket give yourself a hug. Wrapped up warm, let the winter winds blow. Håkan sends warmth, just so you know. So I think that's quite a nice Christmas rhyme. So then for our next Prompty, what we would like to do here is we would like to create an image. So first of all, we would like to create a prompt that describes an image, and after that we would like to use some additional functionality in order to turn this text into an image. So first challenge here is to create this image prompt. So similar to before, we also have a create image prompty, and here it says that this is a prompt that uses a gift item as an input and creates an image prompt back as output. And we provide it with the Azure endpoint, the deployment, and also the API version. And we give it some context that you should take a gift as an input and turn that into an image prompt for DALL-E 3. So the DALL-E 3 is a model that is used to create images. So the image should always be Christmas themed with a lot of red colors and winter details in it. There should be either Santa Claus, reindeers, or the Santa Claus dwarfs in the image. And we provide it with a system prompt. You are an AI assistant who helps people with illustrations for their Christmas gifts. As the assistant, you will write a prompt that DALL-E 3 will use to generate the image. Respond using the JSON format by including the original gift and the image prompt. So we can try this one out. So here we can see again that it's calling our Azure Open AI instance. And then here in this example, the gift is a book. And then the image prompt is this: a beautifully wrapped book placed under a decorated Christmas tree surrounded by twinkling fairy lights and red ornaments. In the background, Santa Claus is joyfully reading the book while cheerful reindeer peek from behind the tree. The scene is set in a snowy winter wonderland with snowflakes gently falling and a warm glow from the fireplace, creating a cozy holiday atmosphere. So now when we have both the create rhyme prompty and the create image prompty, then we can put these two together in a test program, which I have done here. And in this test program, we are first invoking this rhyme prompt. So we set up similar to before. We create here a rhyme prompt from the kernel, and then we invoke this rhyme prompt to get our Christmas rhyme. And then after that we create a second kernel object, and then we provide it with the file path to create image prompt, and then we invoke this in order to get our image prompt. So now we have the Christmas rhyme and we also have an image prompt. And finally what we would like to get is the actual image. So then we're using this pre-built functionality image to text service. And what we do is we are calling a function here, text to image service, generate image async with our image prompt. And then we also have the dimensions here for our image. And then we'll get an image URL where we can download or view our image. So let us try this one out. So then we have a first breakpoint where we can see here the rhyme. So here the gift was a book, and we got the rhyme: Dear Dad, this Christmas a tale awaits, a journey through pages where adventure creates. With every word a new world to see, enjoy the escape, just you and me. So that's our rhyme for a book, and then we invoke our image prompt. And then our image prompt is it's still the same book. It says a cozy Christmas scene featuring a beautifully wrapped book as the central focus. The book is adorned with a red ribbon and sits on a snowy wooden table. In the background there are twinkling Christmas lights, a decorated Christmas tree, and a warm fireplace. Santa Claus is peeking through the window with his sleigh and reindeer visible in the night sky. The overall color scheme is rich in red and white, capturing the festive spirit of Christmas. And then we continue our execution. So then we're calling this text to image service, which will generate an image for us based on the image prompt, and we will get an image URL, which is this one. So we just copy this image URL, and then we will open it up here in our browser. Yeah, so here we can see the results here with the book and the Christmassy background with the Christmas tree and also Santa Claus. So what we have done here is we have used Prompty, which is a tool for rapidly be able to prototype your prompts, and we have used it in Visual Studio Code, and it's very easy. We've seen that it's quite easy here to change our prompt and to rapidly be able to iterate through new ideas that we might have. And then we have also shown that we can put it together into a program so that we can actually see that it works out the way that we want it to. Now I'm going to show you that we can also use this in a more realistic setting in Visual Studio, where we have developed this Christmas rhyme application that we saw at the start of my session. So let me switch over to Visual Studio. Let me stop this for a short while here. So over here we are in Visual Studio, and here we can see that we have a Santa workshop solution, and it's divided into different parts here. We have an app host, we have a Azure AI project, we have a project for models and for storage and so on. So what is maybe most interesting for us is here in the Azure AI project. So what we've done here is we've created a folder called prompts, and in this prompts folder we have just copied the create rhyme prompt to create our Christmas rhyme, and create image prompt to create our image prompt. And then we are using these in this. Let me open up this here. So over here we are using the same type of setup. We create a kernel builder, and then we add this prompted templates, and then we are also creating a service here. So we have one rhyme service. So the rhyme service is taking care of using this create rhyme prompt, and then create or retrieve our Christmas rhyme. So here we invoke our semantic kernel, and we invoke it with the name here of our Christmas rhyme, and we get the rhyme back here as a JSON object. And in a similar fashion, we do the same thing here with our Christmas image fabricator. So then we are getting this the text description, the prompt to generate the image, and then we are using this text to image service in order to actually generate the image based on this prompt. And similar to as we saw in Visual Studio Code, we can also set the size dimensions of our image, and then we return this image back to our calling function. And finally, one thing that I would like to show you is that if we run this program, then we can also see here that we are running .NET Aspire, which is a great tool here if we want to be able to observe and do logging of different parameters. So if we go to this endpoint, and then we generate here a Christmas rhyme. So here we can see the Christmas rhyme, and then we also generate an image. Here we can see the image. Then what we can see here, if we go back to our .NET Aspire here, then we can have a look here at the logs. So here we can see both, for example, here we're calling the Azure Open AI chat completion service, and the prompt was for 408 tokens, and the completion tokens was 49. So the total number of tokens were 457. And we're again calling the Azure Open AI chat completion service, and we have prompt tokens 300, completion tokens 97. And so this is a nice way here of figuring out how many tokens are we consuming and how much time does it take. And all of this is coming out of the box using .NET Aspire. So what I wanted to show here was that we've done prototyping in Visual Studio Code using Prompty, and we can prototype rapidly and iterate, and then we can just take the files, the Prompty files that we have developed in Visual Studio Code, and we can copy them directly into our Visual Studio solution, so that it's a tool that you can use both for smaller projects and also for more enterprisey projects. So let me switch over here to our presentation. So now we've seen some demos, and if you would like to know more about this, you can scan these QR codes. So the first QR code is for the official Semantic Kernel GitHub, and then the second is a Microsoft Learn information here for Introduction to Semantic Kernel. And if you have any questions, you can please write them here in the comment field, and I will try to answer them. And if you would like to know more about me or connect on LinkedIn, you can scan this QR code and we'll connect on LinkedIn. So with that said, I would like to thank you all so much for your time, and I wish you a great Azure back to school. Thank you so much.